Hello and welcome to Psychgeist, where we talk about the psychology of the era, the science of games. I am your host, Dr. Rachel Kowert, and on today's episode of Jargon Schmargon, we're going to be tackling some statistics terms. Think of it as a Stats 101. I thought it was important to make a video tackling basic statistical terms, and so we can move on and then later discuss more complicated statistical ideas. Understanding what these terms mean and what they represent will help you be better able to understand scientific articles and reviews. And that is part of our goal here on Psychgeist, to draw the curtain back from scientific research so it's more accessible for everyone. So we're going to talk about 5 different terms today. First, we're going to talk about N. N is simply shorthand for number of participants. If you see a capital N, that usually represents the entire sample in a particular study, whereas a lowercase n will represent different subgroups of the big N, for instance, gender categories or age categories. The next term we have is mean. Mean refers to an average. The mean is calculated by taking the total number of data points and dividing it by the number of participants. For example, let's say we sampled 5 Pokemon trainers and calculated how many Pokemon they caught. We would get the mean or average of this group by adding all the data points together and dividing by 5. Then we have median. Median is the number that occurs in the middle of the data sample when you arrange the data from smallest to largest. So in this example, if we rearrange the Pokemon trainers, we'll see that the median is 5. Then there is mode. Mode refers to the data point that occurs the most frequently. So again, if we look back at this sample, the mode would be 2. Now those are really the basics. I wanted to add one more term in this episode that's a little bit more complicated, but it's one you've probably heard a lot and it's often misunderstood, and that is correlation. A correlation represents a mutual relationship or connection between 2 or more things. In the broadest sense, it is any statistical association, though it commonly refers to the degree to which a pair of variables are linearly related, which means they change together at a constant rate. For example, as I eat more pie, my pant size might also linearly increase in the same direction. However, if I exercise more, we might see the opposite effect in terms of pant size. Not that anyone is gaining any weight during COVID because of all the stress baking. That is not me. It is me. The strength of the correlation can range from 0 to 1, and the closer to 1, the stronger the relationship, or the more connected those 2 variables are. For example, if being funny was related to how many Pokemon we caught, we would expect Ryan to be the funniest of the group. That checks out. There is a caveat here. Correlations are used to describe simple relationships, not cause and effect. Louder for those in the back. Correlation is not causation. Being funny doesn't make you better able to catch a Pokemon. You don't lure them in with your jokes. There are a whole host of other things that can make Ryan a better Pokemon trainer. He could have had a better breakfast that morning, or he could exercise more, or a whole host of other things. A correlation simply means the 2 variables in the data set are related. So let's review. N is the number of participants in a particular sample, with the big N representing the whole sample and smaller n representing different subgroups of the sample. Mean is an average in any particular set of data. Median is the data point in the middle of the data set when you arrange the data from smallest to largest. Mode is the data point that occurs most frequently in the data set. A correlation is a linear association between 2 variables that represents a relationship but does not imply causation. If you like this video, please like and subscribe, and until next time, be excellent to each other and always cite your sources.